So we now want to develop an inverse function for the sine of x. What's the problem? It's not 1 to 1, right? It's not 1 to 1. So one of the hardest parts about working with the inverse trig functions is realizing that you're no longer dealing with the entire sine curve. Because the entire sine curve is not 1 to 1. So what are we going to do? We're going to restrict ourselves to just a 1 to 1 portion of the sine curve, and we have to always be cognizant of what that was. Okay? So let's look at this. Let's put up a rough sketch of a sine curve. Maybe it looks something like this. Let's see here. Okay? And it continues on periodically, right? Very not 1 to 1, right? Every horizontal line that intersects the graph intersects it infinitely many times. Very not 1 to 1. I would like to now come up with a natural 1 to 1 segment. For the sine, cosine, and tangent, and cotangent, everyone agrees as to what a natural 1 to 1 segment is. I would like to get a 1 to 1 segment that is as long as possible, sort of fits with what you would hope for. So where's a nice long 1 to 1 stretch of this curve? Well, let's go from one peak to one valley, or from one valley to one peak. That's the longest stretch we could go for. So what should we do? Well, I think we should go from this valley to this peak. That's the most natural choice. Anything else would seem a little strange. Okay? So what's our restricted domain? Our restricted domain is from minus pi over 2 to pi over 2. Now this graph passes the horizontal line test. Now it's 1 to 1. So now we can define the inverse of not the entire sine function, but just this segment here. So we define f inverse of x to be the arc sine of x. That's its inverse. Okay. Arc sine of x can also be written, unfortunately, it's just 3 letters. What's wrong with writing some extra 3 letters? Unfortunately, we can also write the arc sine this way. I tend to avoid that, with the exception, I feel like I need to show you a little bit because you're going to encounter it out in the wild too. Okay? But I really dislike this notation for reasons I've already ranted about with you. But let me just show you this to make sure that, now, I told you earlier, hey, folks, when you see sine squared of x, if you're confused about that, go ahead and write it as sine of x squared, because that's really all it's shorthand for, and that was true. And by writing it this way, it just made your life easier. Same thing if we had sine to the 3rd power of x. That would be the sine of x to the 3rd power. Sine inverse of x, though, does not equal sine of x to the negative 1 power. What does it equal? It equals the arc sine of x, the inverse sine function, which is not the same thing as 1 over sine of x. So 1 over sine of x and sine inverse of x are not the same thing. What is 1 over sine of x? Cosecant. Cosecant is not the inverse sine function. Okay? So, whereas this is just confusing, and I think it makes your life, this expression right here, that's just confusing when you're doing a chain rule and causes people to make mistakes all the time. This is downright criminal, right? So I've got a petition where we need another 199,999 signatures. I got one. Okay, we're going to petition. We're going to get this thing changed. We're going to write our congressman. Okay, we're going to. This is silly. All right, that's my rant. Anyway, that's why I use arc sine. What's that?
Thank you for coming to my TED Talk.
Yeah. That's my rant. All right. So now let's be a little bit careful. If f is the sine function and f inverse is the arc sine, let's pause for just a moment to identify the domain and range of these functions. What's the domain of the sine function when we want to work with the arc sine? The restricted domain, what is it? Negative pi over 2 to pi over 2. Now what is always the, well, for that little peak to valley to peak, what is the range of that segment of the sine function? It is -1 to 1. Okay, that gives you an insight as to the domain and range of the arc sine. To be honest, folks, I don't remember the domain and range of the arc sine. I remember the domain and range of the sine, and then I do the flip-flop as appropriate. Right? So what is the domain of the arc sine? -1 to 1. What is the range? What is the output? -π/2 to π/2. That means that in a story problem where you have to use the inverse sine function, or in any math problem where you have to use the inverse sine function, it will only output values, angles between here and here. If you intended it to output something different, you have to make an adjustment, which is why working with these is always so difficult. Okay? All right. Let's sketch the two on the same coordinate system, just for fun. Let's see here. Let me put a box of 1s around here. And then let me put a box of pi's over 2s. Pi over 2 is, I don't know, 1.57 about, yes? No, 1.507? Thereabouts. Okay, so what was the sine function? That's the easiest one to graph. Let's graph that sine function again. Let's see here. We took it from -π/2. Oops, excuse me. We took it from -π/2, and at -π/2, its sine value was -1. And we went all the way up to π/2, where its sine value was 1. And so here is the sine function right there. Okay, so where's the inverse sine function? Well, its domain, what's its smallest domain value? -1, and when we input a -1, it outputs a -π/2. The arc sine of -1 is -π/2. And when we input a 1, it outputs a π/2, and we get something like this for the inverse sine. So this is the sine of x. Okay? I'm not going to be careful. This is technically the sine of x restricted to the domain -π/2 to π/2. And this is the arc sine of x. It's inverse. Notice, it's a little hard to put the graph on there. I'll maybe put part of it on. Notice that this is still, this is still symmetric about the line y = x, right? As we said it should be. What's that?
I said it's pretty nifty.
It is pretty nifty. Yeah. I was hoping you said it was pretty.
Also that.
I've had people say it's pretty. You put a function in, it's the inverse up, and it looks pretty. How come? There's symmetry, right? That's like one of the things of art, right? Symmetry. All right. All right. Questions on that, folks? Okay. Next page. Okay. Let's come back and fill in these restricted domains here for just a second. I want to say, we'll come back and we'll catch up with that in just a second. This is the most important thing, I think, for working with trig functions and the inverse trig functions simultaneously. Okay? And this is an important math skill. What type of object do you plug into certain functions? Ask yourself that question. It helps you out immensely. Okay? Nobody taught me that. It was just something I kind of discovered over the years. Ask yourself, what thing goes into this function? What do I take the sine of? What do I take the sine of? Well, you know, sometimes maybe π/2 or 30 degrees. What are those things? Angles. We take the sine of an angle, and what does it return? That's kind of a tricky question. What is trigonometry really all about? Not length, not quite. Now, if you're pulling just from the unit circle, maybe that's what you meant. Doesn't return a degree. So remember that first phrase you had to memorize in trigonometry? SOHCAHTOA. What was the O? Opposite over hypotenuse. What is that? It's a ratio. It's a ratio of the lengths of the sides of right triangles, right? So when you take the sine of an angle, it returns a ratio. Okay? I know you all know that, but I want you to focus on that. Okay? So then when I take the arc sine of something, what do I take the arc sine of? I take the arc sine of a ratio, and it returns an angle, right? So now all of a sudden it should sort of make sense. What was the domain of the arc sine? What's that? Yeah, negative 1 to 1. What is the ratio we're talking about? We're talking about the ratio of the opposite side to the hypotenuse. And the hypotenuse is always the longest, so the biggest that ratio could be is 1, or negative 1, or all values in between. So it makes sense that that's the domain. All right. Let's do a couple of these first, then we'll go back and we'll fill in some of the values. Oof, I'm scared. I don't do this very well. All right. What is the arc sine of the square root of 3 over 2? Oh, excuse me, minus the square root of 3 over 2. Okay. Well, what is this thing? It's a ratio. Okay. If you like, you could rewrite it as the ratio, because we're not used to seeing it that way. Let's say minus square root of 3 over 2 all over 1. Now it really looks like the unit circle ratio. Okay. What angle, when I took its sine, returned the ratio minus square root of 3 over 2? Well, on the unit circle, the sine value is the height, and minus square root of 3 over 2 would be down here or down here. There are two angles, two principal angles on the unit circle that return sine values of minus the square root of 3 over 2. Which one do I want?
Quadrant 4.
I want the one in quadrant 4. Why? Because what does the arc sine output? It outputs angles between minus pi over 2, which would be down here, minus pi over 2, and pi over 2. So which one do I want? I want this one here. What angle is that?
Negative pi over 3.
It would be negative pi over 3. Now, if from the context of my problem, I want that to be a positive angle, I would call that 5 pi over 3. But I don't say 5 pi over 3. How come? Because it's got to be an angle between minus pi over 2 and pi over 2. Okay?